Hi friends, my name is Joe, and in this video we are going to discuss about the topic inter-process communication in operating system. And let us go and discuss in detail. Introduction to inter-process communication. What is inter-process communication? And definition and basic concept we are going to discuss in this video. Why inter-process communication is important? Because it enables processes to communicate and synchronize their action, essential for multitasking operating system. Inter-process communication is important in operating system because it allows programs to work together, share data, and coordinate actions. Without inter-process communication, programs would run in isolation and would not be able to communicate. And so IPC is important in operating system. And next, types of processes. And there are two types of processes in this, and they are independent processes, cooperative processes. In an operating system, an independent process refers to a process that can execute completely on its own without needing to rely on or interact with any other processes to complete its task. Essentially, it does not affect or get affected by other running processes in the system, meaning it operates independently. And the next, cooperative processes. A cooperative processes in an operating system is a process that can affect or be affected by other processes in the system. Cooperating processes can share data or code, or they can share data through files or messages. This is the two types of processes. Next, IPC mechanism overview. Main mechanisms: shared memory, message passing, pipes, sockets, and signals. These are the inter-process communication mechanism overview. First, shared memory. Shared memory. The processes share a region of memory and faster data exchange. Example, POSIX shared memory. Message passing. Message passing. The processes communicate by sending and receiving messages. Example, MPI, message passing interface. This is about message passing. And now pipes. Data flows in an unidirectional way. Data flows in a unidirectional way. This is called as pipes. And there are types, and they are named pipes and unnamed pipes. And now sockets. Sockets allow communication between processes over a network, and it is used in client server models. And this is about the sockets in operating system. Signals. A synchronous notification sent to a processes. And example, SIGINT, interrupt. This is signal in operating system. Semaphorous. Semaphorous means synchronization tool to avoid race conditions. And binary and counting semaphores. Mutexes, mutual exclusion mechanism. It prevents concurrent access to the resources. And this is about the mutexes in operating system. Memory map files. Map files to memory space. Efficient file input output operation. This is a brief about the memory mapped files in operating system. Inter-process communication in distributed system. Communication between processes on different system. An example, remote procedure call RPC. This is inter-process communication in distributed system in operating system. And next, synchronization issues. Common problems, deadlocks, race conditions, starvation. These are the common problems in synchronization issues. Synchronization is an essential part of inter-processes communication. It refers to a case where the data used to communicate between processor is control information. It is either given by the inter-process control mechanism or handled by the communicating. And this is about the synchronization issues. And next, security in inter-process communication. Prevent unauthorized access, use access control and permissions. In the operating system, security in inter-process communication refers to the measure taken to protect data exchange between different processes through inter-process communication mechanism, ensuring only authorized processes can access and modify shared information, preventing unauthorized access, data leaks, and potential security breaches by implementing access controls, encryption, and careful validation of data during communication. Key aspects of inter-process communication security: access control, authentication, data integrity, encryption, and now potential vulnerabilities in IPC, race conditions, buffer overflows, improper access control. How to enhance inter-process communication security? To enhance, use appropriate IPC mechanisms and input validation and secure coding practices and least privilege principle, and at last, encryption for sensitive data. This is about the security in inter-process communication in operating system. And next, advantages of inter-process communication. Some of the advantages are resource sharing, speed, modularity, synchronization. These are some of the advantages of inter-process communication in operating system. And the challenges of inter-process communication: complexity, synchronization issues, security concerns. These are the challenges of inter-process communication in operating system. Real world examples. And first, Unix, Linux, inter-process communication mechanisms, and next, Windows named pipes and shared memory. This is the real world examples of IPC. And the conclusion: inter-process communication is a critical component of modern operating system, allowing processes to effectively communicate, share data, and coordinate their activities with each other, enabling the creation of complex and scalable systems by facilitating collaboration between different processes through various mechanisms like shared memory, message passing, and pipes, while ensuring proper synchronization to prevent race conditions and data inconsistencies. Understanding and utilizing IPC is essential for building robust multiprocess application. Thank you.